All right, we are good to go, and I'm just gonna immediately start here. All right, well, hello everyone, and welcome back to Data Fault. Last night we wrote the create entry, or implemented the create entry sequence, and now we're going to be doing the flip side of that, and we're going to be doing the access entry sequence. So just a few changes that I made after the stream last night. I added these two little macros here that kind of just allow us to simplify or reduce our redundant calls or redundant parameters to the AES encrypt and decrypt value or functions, just because they always have 16, they always use the same key schedule, they always use the same number of rounds and same mode. So the only thing that's different is just the input, the IV, and the output. So this macro just allows us to simplify things, which is awesome. All right, and then I also added a file copy function here that just reduces the amount of code that we actually have in the controller file. All right, and then today we're going to be actually accessing the data that we just created. So we'll start in the header file with our signature, and it will return an integer dv access entry data. We're going to pass in the app, the name, the category, and this time we're not writing data, we're reading data. So we're going to want to return data to some buffer. And as we did with the AES methods, we can just pass in a reference to a string or just a double pointer of a character. So character double pointer buffer, like so. So we will write to buffer, or write and allocate, or allocate and then write to buffer. Okay. So once again, this method is going to be a very long, but it's very procedural, and a lot of this will look similar to what we had with create entry data. All right, so for access entry data, we're going to start with our first check, which is if we're logged in. So if not dv.loggedin, then return dv logged out. Then, as we did with the create, we need to find the entry and category ID, except this time, if they don't exist, we're not going to create anything. Just because we're accessing it, so if it doesn't exist, then we want to return that it does not exist. So find entry ID. So unsigned integer entry ID is equal to an unsigned integer conversion of AVL get, and we pass in dv.name ID map and a void pointer cast of name, just to avoid warnings. And if not entry ID, then we don't have, then this doesn't exist, or the entry itself doesn't exist. So what we want to do is just return, it's an invalid input. So we're going to just go ahead and return one of the error codes, so dv invalid inputs. And then same thing for category ID, except this time we're going to be getting an unsigned character, cat ID, and this is going to be the same cast as we did before, so it's an unsigned character conversion of an unsigned integer conversion of AVL get. So once again, we cast a void pointer to an integer, both 4 bytes, and then we take the least significant byte. So AVL get, passing in dv.cat ID map, and then the name or the key will be the void pointer conversion of category. And if not cat ID, then once again this doesn't exist, so we just return dv invalid inputs. All right, and then we can have a few debug statements that I will just copy and paste, which are just right here. All right, and then we're going to start with our cursors. we're not going to have any data cursors just because there's nothing to, we don't know what data we're going to be iterating over just yet. But we are going to just be writing to a buffer. So we'll write to a string stream. So this will be str stream. Yes, we have that included. Return is equal to string stream allocate default. And then now we're going to have our block cursors. So unsigned integer previous block is equal to 0, and unsigned integer current block is equal to the unsigned integer conversion of btree search dv.id idx map and entry id. So once again, we're just finding the initial block, and that's where we start our search. And since we don't need to copy any blocks or copy any unused blocks, previous block we will start at 0, and it will just simplify. We don't have to copy an initial block or anything, so we can just start this at 0, which is awesome. And then now we open up our file. So file struct data file, and if file open, passing in a reference to data file pointer, and reading in binary mode. So we're opening up the file, and then we set up to be read from. So we set the block size to 16. And these are just, once again, utility methods that I wrote for the file structure. And then we get the number of blocks. So we do the length divided, right shifted by 4, which is just the length divided by 16. And then once again, we want to skip the first block. This time we're not copying it. We're just going to advance the cursor. So file, advance cursor in blocks, pass in a reference to data file, and 1. So we just move up the cursor. All right, and then we're going to copy our initialization vector. So we create the IV copy is equal to malloc 16 for 16 bytes, and then we do a mem copy, IV copy dv.random plus data IV offsets, and then the size is 16. All right, and then we're gonna have a few switches here, or a few flags that actually will help us navigate through our loop. So these will be conditions to determine whether or not we are done with the message, if we're currently reading the message and we need to skip over a block, so on and so forth. So we'll do bool completed is equal to false, and bool on target is equal to false as well. And then as with the create data, we're going to have an unsigned integer for start index. And this will just be the index that we start reading from instead of the index that we start writing from in the current block. All right, now for our main loop, we have the same driving condition. So while current block is less than number of blocks. So this time, this is going to be our only condition, and the loop is going to be a lot simpler in the sense that we only need to check if we're done with the file. We don't need to check if there's more data to write because we have nothing to write. We're looking at data that already exists and nothing else. We're not writing any data. We're simply reading. All right, and then I guess I could put another variable up with the block counters. Just unsigned integer next block is equal to 0. That's just, we're going to be using this counter to update at the end of the loop, if you guys remember. So we're going to need to skip blocks. This will be incrementing the IV and advancing our cursor. So integer increment is equal to current block minus previous block. And then file advance cursor blocks. Reference the data file and increment -1. So here we do increment -1 because previous block points to the previous block that we read from, not the block after that. In create data, we moved up the cursor because we're writing, but here since we're reading data, actually that doesn't make any sense, but this increment works. This is the same calculation for the increment, except this time the file itself, we read the previous block, so the cursor is already moved up past the previous block. So therefore, we just want to do increment -1. And we want to increment the data, the IV as well. So AES increment counter, pass in IV copy and increment. All right. Then we're going to read our block. So character, yep. So character pointer encrypted is equal to file read blocks. Pass in a reference to data file and 1. And then we're going to have our decrypted values. Unsigned character pointer decrypted is equal to null. And then we are going to use our macro here. So AES decrypt block. It's going to be DV. The input is encrypted. The IV is IV copy. And then the output is a reference to decrypted. So same parameters, except this time we're just eliminating everything that we pass in for all of the calls to AES. So the blocks, or the length of 16, since we're only dealing in blocks. dv.aes key schedule, the number of rounds in the counter mode again. But everything else changes. All right. And then if we'll have a few debugging statements here, which I will copy and paste. Just for that, these are just going to print out the block index, the encrypted and decrypted values. So this allows us to just check that everything is good. All right, and then we're going to say if on target. So on target is the switch indicating whether or not we are currently reading the message. So the structure that we have for the data file is that data can span multiple blocks, and that goes for individual entries. So let's say data is longer than 11 bytes. That will be the case for most things, but so we have to use more than one block, and if we started reading from the last block in the last block, then we also want to start at the beginning of the next block. So that's if on target. And if it is, then we read from beginning. So we set our start index to 0. All right, and then now we're going to scan our data. So we want to have another flag here. So bool scan data is equal to false. And this will be telling us whether or not we're actually reading data or a category ID right now. So we're going to start with our character I, or our counter I, so integer I is equal to 0. We start that outside the loop because we're going to need the final value of that. So for empty first part, I is less than 16 minus I guess we could make this a while loop, but it will convert it. The compiler will convert it either way. So I is less than 16 minus the size of an unsigned integer, I++. So we're just iterating over the data. Once again, this size of unsigned integer accounts for the fact that we have an integer for the continuation block. If not scan data, so if we're not currently scanning data, then this means that we're trying to find a category ID. So if not decrypted at I, then this is the end of an entry. So completed is equal to true and break. So this condition, we'll see how it, we'll see how this condition gets called, but scan data tells us whether or not we are currently, let me just make sure I'm reading this right. Give me 2 seconds to figure out how this works. All right. For now, I'm just gonna leave it like this, and then I will figure this out. So we do if not scan data. So if we are currently looking at sorry. If not scan data, then this means that we're looking at category IDs or the end of an index. If not decrypted at I, then that means that we found a terminator character, so it's the end of the entry. So completed is equal to true. Scan data we will set scan data to true if, right after this. So if not scan data, then after we find a terminator, then we set scan data is equal to true. So this means that we haven't found a terminator character. Sorry. So this will be set to true when we don't find a terminator character. So that's that. And scan data is false. And then if decrypted at I is equal to the category ID, then we found the target. So on target is equal to true, and start IDX is equal to I plus 1. So here we go. So scan data will be true when we are not, when we are just getting any data entry. So any entry data. And we are identifying the current category ID because we have just found the end of the entry. And so we want to find the next category ID. So this loop will start here, and we will go start at the beginning of the block. Scan data is false, so we will enter this block here, right here. And if it's not the end of the entry, then we have completed it. Or if it is the end of the entry, then we've completed. Otherwise, we're going to be scanning data. We're going to set this flag to true, and then we're going to identify the category ID. So if decrypted at I is equal to the category ID, this is the one that we passed into the function. Then we say on target is true because we're currently reading the data that we want, and then we set the start index to the one after the category ID. All right, and then if not decrypted at I, then we have read. Then we're done with a piece of data. So scan data is equal to false, and then if on target, then this means that we have finished the current data for our target. Finished reading target. So completed is equal to true and break. Yeah. I need to iron this out because I think that's how it works, but I'm not sure why we set completed to true. Oh, this might have been assuming that, this may be a preliminary thing where we might have been assuming that the block would have just been all zeros. So it was thinking, oh, if we're not scanning data and we're finding a terminator character, then we're done. But I don't think this is, I think we can delete that for now, or I'll just comment it out for now. But essentially, if we are not scanning data, then we're on a category ID. So we set scan data to true for the next iteration, and then we say if decrypted at I is equal to the category ID, then we are on target. And then if we are scanning data and we have found the terminator character, then we set scan data to false. And if we're on target, then that means that we found the terminator character for our target data. All right. Now after the loop, we have our value of I, and we're going to say if on target, then we are going to read characters or write characters to the buffer. So we're going to say string stream read, and we're going to pass in a reference to ret, and then the data will be decrypted plus start index. So we're setting our cursor in the decrypted block, and the length will be I minus the start index. So I here is either the end of the block, because that's what happens when this condition here, or it's the terminator character for our target. All right, then we're going to read our continuation block. So next block is equal to the small endian value of decrypted plus 12 and 4. So we're just getting the last 4 characters, and then we free our encrypted value and also free our decrypted value. And then if we completed or it's not next block, then we're done. So we either completed the entry or read all the data, and we break. So completed will be set to true if we have read the termination character for our target. Next block will be 0 if there is no more data corresponding to this entry. And if we have not read data, then this means that we have an invalid category because the entry does not have any data mapping to the category. All right, and then otherwise we're going to update our counters. Actually, we don't even need that else block. We can just write it right here. So update counters. So previous block is equal to current block, and current block is equal to next block. Just like so. All right, and then we're done with the main while loop, or the main while loop we're done with here. Then we want to go ahead and file close, pass in a reference to data file, and then free the IV copy. And if not completed, then once again, we have no data, so the data does not exist. So we clear the string stream, our return buffer, and then return the invalid input error code. All right, and then we're done there. And then the big if statement for the file open, we forgot the else block, but it'll be else. And otherwise we're gonna return dv file does not exist, just that error code. And we also need to free the string stream because we did not do that. So we need to string stream free, or it's clear. Pass in a reference to ret. You know what, this might call for our do while loop. I'm just thinking because we're replicating this clear a lot. Let me see. All right, let's just go ahead and proceed as planned. So now we're going to set our return value. So this is passing a dereference buffer is equal to malloc ret.size plus 1. So we're taking the return value, or the return string, sorry, and we're going to allocate it. And then we copy the memory over. The destination is dereferenced to buffer because buffer is a double pointer. And then the source will be ret.string, and then the size will be ret.size plus one for the terminator character. And then we clear our string stream, pass in a reference to ret, and then we return dv success. And yeah, so this was a lot quicker than I thought, but we have a few optimizations that we can do. So I'm gonna remove this statement here, or actually I'm gonna make this all under a do while false loop, just because we will return. There's 3 return statements here, and all of them are preceded by string stream clear ret. So what we want to do is let's just make this a do while false loop. So we're going to put the do while false around the file open. So do while false. This block will only execute once. And we are going to have our return code. So integer ret code is equal to dv success. And then after the do while false loop, we're going to free the string stream. So string stream clear, pass in a reference to ret, and then return ret code. And then we need to take everything that we already had, so from the data file to the return. Oops, that's not right. No. So from initializing the file to the end, we're going to cut and paste that into the do while false loop. And then I'm going to get rid of all of our calls to return to clear the string stream. And then we're just going to, every time we want to return, we're just going to break out of the loop. So for the data does not exist, we say ret code is equal to dv invalid inputs, and then we break, and break will send us over here. And then I'm going to worry about the file in a second. All right, and then this is already taken care of. So now for the file block, what I'm just going to do is, instead of having an if true just to reduce the amount of times that we're indenting our code, we're going to say if not file open, then we're going to set our error code and return here. So set ret code is equal to dv file does not exist, and then break, and then the rest of this stuff does not need to be in a block. So we have if not completed, blah, 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 blah. Okay, nice. So we're kind of replacing just a few things with just the do while false. And this also just allows us to bring everything that was in the if file open that we usually have and just bring it out. So less indentation allows for cleaner code and less confusion. Okay. Now let's go ahead and test this out. So in our main file, we have this here, and we're going to do a printf for access data 1. So we're going to have the buffer will just be our output, and then we'll just call our function here. So dv access entry data, pass in our referenced app, GitHub is the name, username, and then the buffer will be a reference to buff, and then we'll print it out. And then same thing for access data 2. And dv access entry data, pass in a reference to app, GitHub, and password, and pass in a reference to buff. And then we're going to printf the buffer as well. So we're just calling the method twice. I'm actually just going to have a return code just for all of these methods, and we'll just print them out, just so we can actually ensure that what is happening is proper, and we're returning this nicely. And we'll just do a bit of a printf on the return code. Okay. I'll just copy this print statement a few times. And then if not, ret code, like so. Okay. So what's going to happen now is we will actually get the return value from all of these functions, just to make sure it's all 0. And then what we can also do is I'll test to make sure that if it doesn't find the data, then we're good to go. All right, so let's go ahead into our test directory and run. All right, we have yes. My debug statements used print string instead of print hex string. Oop, nope, not that. Okay. Okay. So let's see. Return 0. All right, perfect. So we insert our data, blah, 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 blah. Create data 2. And accessing data 1, username will be return 0, Micah, and then Micah 2 for the password, which is wonderful. You don't understand anything right now. Uh-oh. Do you have anything specific? Because I can go back to a few things. We're currently in this method here. All right. So yeah, that's good and good. And I can also test to make sure that we have a valid input. So let me try passing in an invalid category. And I'll actually turn debug off for everything before the access. Actually, let me just turn it off just to show you, just to make the output a little cleaner. All right, so access data 1, we return 3, and 3 is invalid input, which is what we want. And it would be the same. So let me just try. Yeah, so that's good and good. I think that's it. I'll just run through the access method one more time. Oops. No, I'm just going to find these print statements that I had that were not contained in a debug block. Oop, I guess they all were. Okay, so for the access entry data sequence here, start by our logged in flag. We find our entry ID and category ID. If neither exist, then we just return invalid input, print that stuff out, and then we allocate our return buffer, which is just our string stream. We get our block cursors, similar to create entry, so the previous block, current block, and next block. We have a return code. And the return code guides what we are going to return after we go through this do while false loop. So every time we want to just stop execution and go to the return sequence after and clear all the variables, then we can just break out of this do while false loop. So we do a file struct here on the data file, and then we're gonna open the file. If it doesn't work, then we set our return code to file does not exist, and we break. Otherwise, we're going to set up the file block size to 16, get the number of blocks. That's just for a cursor. And then we skip our first block because, once again, that's just a garbage block. We don't technically need that, but it's just there to keep something in the data file. Then we copy the IV, which is all there, and then we have a few flags here. So completed determines whether or not we're done with the target. So we have completed the target message. On target determines whether or not we're currently reading from the target data. So these variables are persisted outside the main loop because data can span multiple blocks. So if we start a new block and we're currently on reading data, we want to start at the beginning. So that's why this on target flag is here. And then we start our main loop, which just reads through the blocks. We're going to skip the blocks that we don't want to read. So we'll be jumping around based on the continuation blocks. Then we read and decrypt our block and print that out there. And if we're on target, then we're going to start reading from the beginning. Otherwise, we're going to be scanning our data here. We always scan the data, but we're going to start by setting our start index. And we will set the start index in here if we have found the data. Or if we have found our category ID. So we have our scan data flag here, and we start our counter, iterate left to right, so beginning to end. And we start by saying if we're not currently scanning data, sorry, give me 2 seconds, there's a fire truck going by. Okay. If we're not currently scanning data, then we are at a category ID, so we want to determine, all right, if this is our target, then we have found the target, so we're going to set that on target flag to true. And we're going to set the start index there. Let me actually, scan data should actually just be set to on target. Should it be? Sorry, hold on. This could be a little wrong, but I will look back at this. Okay. So we have if not scan data, then we do that. And then if not decrypted at I, then we have found a terminator character. So we're done scanning data, which is by setting scan data to false. And then if on target, then we are completed. So if we're currently reading the target data, then we set completed to true, and we break out of the loop, break out of the this scanning loop here. And if we're on target after the loop, then we want to read to the buffer. Then we set our continuation block. And if we're either completed or there's no more data to read, then we stop and break. And then otherwise, we're going to update our counters. And then we close our files and set the return value. And yeah, so we did a bit of testing. I will look back at a few of these things because they were a bit uncertain. Specifically this scanning loop here. I think making scan data, I'm just gonna make scan data another flag over here. So this will persist over multiple blocks, which that's what has to happen. This needs to be, sorry, there is a fire somewhere. But scan data needs to be persisted over multiple blocks because once again, data can span multiple blocks. So let me give you an example. If we had a category ID of 65, which I believe is A, and there was data that started in one block and continued into the next one, and the first character in the next block for that data was 65 or A, then not scan data would be true, and it would read category ID, and it would say that we're on target, and it would read invalid data. So this needs to be persisted throughout our loops. So yeah, that is pretty much it. It was a bit of a shorter video, but I kind of strung it out longer than needed. But I will once again look through the code and figure out what we need to look at here. Yeah, so hope you guys enjoyed, and next we will be looking at our the view code where we'll be implementing an interface in the console. So yeah, I hope you guys enjoyed, and I will see you guys in the next one. Stay safe.